All right, morning, folks. So now we want to look at factorizing using the difference of squares, right? So again, when you factorize using difference of squares, so let's start by understanding what difference of squares mean. So this is a square, and that's a square, and this is difference of squares. So when you factorize difference of squares, what you do is you take the square root of the first term, then you take the square root of the second term, take the square root of the first term, take the square root of the second term. Notice that the brackets will have alternating signs. So if you have negative, that's going to be positive. If this was positive, then that would be negative. And then from there, the square root of x squared is x minus y, then x plus y. So what is important here is for you to remember that whenever you take difference, whenever you want to factorize using difference of squares method, you must take the square root of the first term. Now, all right, now I want to explain something further. I want us to understand what this thing actually means. So if you have, let's say, a to the power of n, what does the square root actually mean? It means that you are basically having an exponent 1 over 2. So the square root symbol is basically meaning that you are raising whatever you have to the power 1 over 2. Now, which is the same as saying a to the power n over 2. So whatever power that you have, you divide it by 2. Now, so this is going to be important because if you have something like this, x to the power of 8, it means then this is going to be x to the power of 8 divided by 2, which is x to the power of 4. So when you take the square root of x to the power of 8, you're basically dividing this exponent by 2 to get 4, right? So those preliminaries are going to be important. Now let's start moving for the sake of time. Now here, A, we have 9a squared minus 81 b squared. So first thing first, 9 is a square of 3, and then 81 is a square. So I can use difference of two squares. Then we take the square root of the first term, take the square root of the second term, take the square root of the first term, take the square root of the first term, plus take the square root of the second term. So that is 3a minus 9b, 3a plus 9b sharp. So something like that. So here it means 3a minus 9b, then 3a plus 9b. Sure. Then let's look at b. So for b, we have 64 minus 81 c squared. Firstly, 64 now 64 is a square, and then 81 is also a square. So this is difference of two squares. Therefore, again, you take the square root of 64, it's 8, minus square root of 81 is 9, c, then 81. 8 plus 9, C. So this is 8 minus 9C. 8 plus 9C. Okay. Then C, what do we have here? We have the square root of 49 is 7. Square root of C squared is C. Square root of D squared is D. Minus the square root of 16 is 4. Then same applies, plus 4. And here we have the square root of the square root of 16 is 4. Now the square root of a to the power of 8, remember, is 8 divided by 2, minus the square root of 1 is 1. Then 4, a to the power 8 divided by 2 plus 1. Now this is equals to 4a to the 4 minus 1, then 4a to the 4 plus 1. Now notice that 4 is still a square. A to the 4 is a square. 1 is a square. So this is difference of squares. So it means we can still continue. Yeah. So this is now square root of 4 is 2. Then square root of a to the power of 4 is a squared minus 1. Then 2a squared plus 1. This one doesn't change because this is not a difference. This is a sum. The sum doesn't change. Right, and then from here, well, you can leave it here. There's nothing wrong if you leave it here. But we can still continue. And then if we continue, then the square root of 2 is square root 2. Square root of a squared is a. Square root of 1 is 1. Then square root 2a plus 1. And then 2a squared plus 1. Then 4a to the 4 plus 1. Yeah. It's our solution. Oh. All right, so square root 2a minus 1, square root 2a plus 1, then 2a squared plus 1, 4a to the 4 plus 1. Sharp. Then let's look at E. For E, we have 27x to the 4 minus 48 x squared y squared. Again, so here, 27 is not a square, right? And 48 is also not a square. So whenever you get a situation like this, you first need to check if there's a highest common factor between 27 and 48, right? So what is that highest common factor? Is there any? You see, you notice that 27 is 3 to the power of 3. Then what is 48? 48 is 16 times 3 x squared y squared. So, you can see that 3 is common. So if I take out 3, I'm left with 3 squared x to the 4 minus 16 x squared y squared, right? And then this is 3, 9 x to the 4 minus 16x squared y squared. Sharp. So now notice that 9 is a square, x to the 4 is a square, 16 is a square, these are squares. So we can now use difference of square method. The square root of 9 is 3, square root of x to the 4 is x squared minus 4xy, then 3x squared plus 4xy. Sharp. So that is our solution for this one. So we have 3x squared minus 4xy, 3x squared plus 4xy. Sure. Okay, now let's look at f. Ooh, and f looks like it's going to be long, but let's see. 25x to the 8 minus 121 y to the 8. 25 is a square, 121 is a square, so we can look at difference of squares. 25's square root of 25 is 5. Square root of x to the 8 is x to the 4. Minus square root of 121 is 11 y to the 4. And 5x to the 4 plus 11y to the 4. So we can do it like that. Well, we can do it like that, or we can, let's just leave it like that. So we said this is equals to 5x to the 4 minus 11 y to the 4, then 5x to the 4 plus 11y to the 4. Okay. Then let's look at G. G, 16x squared plus 25y squared. Notice that this is not a difference. This is a sum. And so we cannot factorize the sum. So there's nothing we can do with this one, right? Because it's not a difference, but a sum. So we can just leave it like that. Okay. Now let's look at H. H, we have 288 x to the 8 minus 64y to the 16. 288 x to the 8 minus 64 y to the 16. So what is the highest common factor there between 28 and 64? I don't know. So let's prime factorize very fast. 288 and 64. So 2, 1, 4, 4, 2, 7, and then twice, then 2, 3, 4, 2, 1, 7, and 17. So that is 2, 8, 8 is equals to 2 to the 4 times 17. Then here we have 2, 2, 3, 2, then 2, 2, 8, 2, 4, 2, 2, 2. So 64 is 2 to the power of 6. Yeah. So what is HCF here? So my HCF is going to be, so we take the one that has the smallest exponent. So between 2 to the 4 and 2 to the 6, we take 2 to the 4. 17 is not common. So my HCF is 2 to the 4 is what? Is 16. Sure. So it means the highest common factor here is going to be 16. Okay. Now that we found it out, now let's take out 16. If we factor out 16, what do we have? We're left with 288 divided by 16 is all right. 16 goes into 28 and in there about chat. So 18 x to the 8 minus 16 into 64. That one we know is 4. Then y 16. Now still 18 is not a square. So we can take out the highest common factor again, which is 2. Take out 2, we're left with 9 x to the 8 minus 2. Something disturbed. Okay, 2 y to the 16 sharp. So that's 32. And 9x to the 8 minus 2y to the 16. Okay, so this is what we have. This is what we have. So from there, we can see that now we have, this looks something like a square, and that's a square. So let's start moving. So from here, we can then say square root of 9 is 3, square root of x to the 8 is x to the 4, minus square root of 2 is square root of 2, square root of y to the 16 is y to the 8, and do the same thing. Sharp. So we have 32, 3x to the 4 minus 2y to the 8 and 3x to the 4 plus 2y to the 8. Sure. Okay, looking at I, 3a plus b is a square minus c squared. So this is 3a plus b minus c, then 3a plus b plus c. Check. Then here we have 13a minus 10b squared, then 13a plus 10b squared. Sure. All right. Okay, folks, let's stop here. So in the next video, we'll look at factorizing trinomials. Okay, thank you so much. Please like and subscribe and share. Danko.